Welcome back everyone. In this video, now we will solve from question 5 onwards. So what is question number 5? Distinguish between parametric versus non-parametric models and supervised models versus unsupervised learning. Um, what is parametric models? It is models assume data follows a specific probability distribution with fixed parameters. What are its key characteristics? Fixed number of parameters determined before learning. Assumes specific data distribution. Parameters estimated from training data. Less data required and faster training and prediction. It is less flexible if assumption violated. So we will so now examples of parametric models are linear regression. In which model y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus epsilon. Fixed parameters. In this fixed parameters are beta 1, beta naught, beta 1, beta 2. Assumption linear relationship plus normal error distribution. Logistic regression. Fixed parameters coefficients w. Assumption logistic sigmoid relationship. Binary outcome p of y equal to 1 equal to 1 upon 1 plus e to the power minus wx. Naya base fixed parameters p of features class. Assumption is features conditionally independent given class. Okay. Yeah. Real world use cases predicting house price continuous. Model is price 5 lakh plus 0.5 into area plus 0.2 into rooms. Parameters learned coefficients from training data. Assumption linear relationship exists. Data needed moderate 100 to 1000 records. Advantages of this is interpretable, clear parameter meanings, computationally efficient, works well with small amount of datasets, theoretically foundations well established. What are its disadvantages? Inflexible if assumptions violated, maybe interpret complex relationships, requires manual feature engineering. Okay, what are non-parametric models? Its definition is models make minimal assumptions about data distributions. Number of parameters grows with data. Its key characteristics are parameters determined by data, flexible data complexity, few distributions assumptions can capture complex patterns. It requires more training data and prone to overfitting. Computationally expensive. It can be expensive. Examples are k nearest neighbors, k and algorithm. No fixed parameters, learns entire training dataset, stores all training data points, classification based on k nearest neighbors, decision trees, tree structure grows from data. Number of nodes splits determined by data, recursively splits on feature maximizing information gain. Random forest. Ensemble of decision trees, number of trees is hyperparameter but structure data driven, captures non-linear relationships. Support vector machines. Real world use cases, face recognition, non-parametric neural network scenes. Parameter grows with data complexity, learns intricate facial feature patterns, data needed large 1 lakh plus images. Its advantages are highly flexible, adapts to any pattern, can model complex relationships, few assumptions needed, works well with large datasets. Its disadvantages are less interpretable, black box, computationally expensive, risk of overfitting, requires large training datasets, slower prediction time. Okay, parametric versus non-parametric. Here is the table given. Read it. Then now have a look difference between supervised versus unsupervised learning. What is supervised learning? Learning with labeled data. Models learn mapping from input to output. Its components are input features X, customer age, income, credit score. Target levels are Y, like approved 1 and rejected 0. Training data X1, Y1, X2, Y2 to X and Y. Learning processes, training data. First is training data which is labeled. Then model learns, pattern recognition, input processing, then output, minimize errors by predicted by actual, then training model. Its examples are classification, predict discrete classes, email classification, this is diagnosis, credit approval algorithms, Number 2 is regression. Predict continuous values like house price prediction, stock price forecasting, temperature prediction, algorithms like linear regression as we have read numbers. Real world example is loan approval. Here you can see an example of trending data. Here age, income, score and approved. There are 4 columns given. Model runs if age greater than 25 and income greater than 6 lakh and score is less than greater than 70, and then now see advantages of supervised learning: clear performance metrics, accurate predictions possible, well-developed algorithms can handle various data types. Disadvantages are requires labeled data, expensive labels can have noise errors, class imbalance problems, overfitting to specific labels. What is unsupervised learning? Learning without labels. Model discovers hidden patterns in data components are input features x only, no target variable y unknown, training data x1, x2 to xn. Learning process is unlabeled data. Model explores pattern discovery, find groupings, relationships, structures, then no explicit error to minimize discovered clusters or patterns. Examples are clustering, group similar data points, dimensionality reduction, reduce features, anomaly detection, find unusual patterns. Real world examples are customer segmentation, marketing data, no labels, spending frequency, recency, and rating. These are 4 columns for marketing data. K-means clustering, let's say K equal to 3. Cluster 1, high spending, frequent VIP customers. Cluster 2, low spending inactive, at risk. Cluster 3, medium spending, regular, loyal. um, marketing actions, VIP loyalty programs, exclusive offers, at risk वालों के लिए reactivation campaigns for loyal customers, regular communication. At its unsupervised learning के advantages क्या है? No labeling required, cost effective, discovers unknown patterns, exploration and discovery focus, works with raw data. Disadvantages are hard to evaluate, performance, no truth, results may be subjective, computationally expensive, requires domain expertise to interpret. Supervised versus unsupervised comparison. It is a table for given. Let's have a look after this session. Next question is, what is text mining matrix? Text mining matrix evaluates classification model performance using confusion matrix. Confusion matrix is given here. Actual spam, not spam, true positive, false positive, false positive, true negative. These are its components are true positive, true negative, false positive, and false negative. Examples is this is the table for what we can say is confusion matrix is this. 45 is the true positive, 5 is the false negative, 40 is the true negative, and 10 is the false positive. Number 1 is accuracy. For a percentage of correct predictions out of total. Formula of accuracy is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative, equal to after calculating accuracy is 0.85 means 85%. Interpretation, model correctly classified 85% of all emails. मतलब 85% एक्यूरेसी है कि मॉडल सही काम कर रहा है, करेक्टली क्लासिफाई कर रहा है. इसको कब यूज कर सकते हैं? बैलेंस डेटा सेट, सो इक्वल क्लासेस, ऑल एरर्स equally important, overall performance needed, limitations are misleading with imbalanced data. If 19% emails are ham, and then marking all as ham because gives 19% accuracy, useless. Number 2 is precision of emails prediction as spam. What fraction are usually spam? Kitna spam? Reliability of positive predictions. Precision, true positive divided by true positive plus false positive. Calculation, precision equal to 45 divided by 45 plus 10 equal to 45 divided by 55. 0.818 or 81.8%. Interpretation, when model predicts spam, it is correct at 1.8% of the time. Real world cost analysis. False positive, FP equal to 10. User sees legitimate email in spam folder, annoying. Precision of 81.8% means 18.2% legitimate emails incorrectly marked as spam. When to use? False positives are costly. Email spam, legitimate emails lost, medical screening, hiring screening. Its focus is how many positive predictions are read. What is recall? Of actual spam emails, what fraction were found, covering of positive class. its formula is true positive divided by true positive plus false negative. After calculating, we call this 0.90 means 90%. Model correctly identified 90% of actual spam emails. Okay, then real world cost analysis false negative. This recall of 90% means 10% of email gets through. Spam gets through. When to use false negative as costly security fraud detection. It focuses how many extra positives were called. Now F1 score. Definition is harmonic mean of precision and recall balanced metric. F1 score is equal to 2 into precision into recall divided by precision plus recall. Calculation after calculating F1 score is 0.857 means 85.7%. Interpretation balanced performance considering both precision and recall. It is the harmonic progression of precision and recall. Why harmonic mean? Harmonic mean penalizes extreme values. If precision 100%, recall 10%. Arithmetic mean 55%, harmonic F1 18%. Probability reflects poor imbalance. How to use imbalanced datasets? Both false positives and false negatives costly. Need single balance metric. Typical choice for classification evaluation. Practical comparison is given in this table. Read this. Real world scenarios is scenario on medical disease screening, cancer diagnosis test, scenario 2 is email spam filtering, scenario 3 credit card fraud detection. अभी कैन फाइंड मतलब इस इन फॉर्मूला से अपन निकाल सकते हैं कितना स्पैम होता है और कितना जैसे मेडिकल हिस्ट्री में कितने फेलियर्स कितने पासेस होते हैं सर्जरी में या फिर किसी भी चीज़ में. ईमेल स्पैम में भी देख सकते हैं अपन कितने स्पैम आते हैं किसमें कितना नॉन स्पैम करता है. इन सबको फिल्टर आउट करने की strategy maximize precision. Accept lower recall. Some spam gets through. Protects user emails. Better to miss some spam than delete legitimate email. Scenario 3 credit card fraud detection. कितना fraud होता है कितना नहीं होता है ये सब भी अपन इससे निकाल सकते हैं. Now question number 6 is missing data handling. How are missing values handled? Suggest 3 approaches. अपन कॉम्प्रेहेंसिव कवरेज फॉर प्रीवियस सेक्शंस इसमें मतलब मिसिंग वैल्यूज को अपन हैंडल कर सकते हैं कैसे. या तो मीन मोड मीडियन अपन ने जैसे पहले देख चुके हैं अपन पिछले क्वेश्चन में कि अपन या तो मिसिंग वैल्यूज को मीन मोड में एक तो होगा कि मीन मोड मीडियन से अपन रिप्लेस कर सकते हो वैल्यू को. बाकी जो रेस्ट वाले जो डेटा सेट से जो गिवन है उनका मीन मोड या मीडियन कुछ भी निकालो उसको फिल कर दो है ना उस मिसिंग वैल्यू में. या फिर एक और अप्रोच हो सकती है कि के नियरेस्ट algorithm से के नियरेस्ट नेबर algorithm से KNN algorithm. और so we have read it in the previous video so you can watch it. Now question number 6 का B वाला क्या है. Explain logistic regression and use the logistic function to calculate the probability of a class for a given input example. It is also we have learned earlier and so go and watch it that one. Question number 7. K-means clustering. What is K-means? Explain the K-means clustering algorithm with steps. Discuss how initial and centroids influence. Now question number 8. Comparison descent trees, random first and boosting highlights, descent and weaknesses of each. Descent trees, random first and boosting highlights. Okay, show how basic logic gates can be built using single layer and neural net and as complete table. Number of neurons are they filled up in this table and then see the answer. So now at last we will see some conclusions from the and same question paper. This comprehensive examination of introduction to data science covers all critical concepts. First, from CRISP-DM frameworks. It is systematic approach to real-world machine learning projects. Probabilistic methods, Bayes theorem and Bayesian classification. Statistical distributions are understanding data characteristics, data handling, practical data cleaning and transformation. Feature engineering, creating powerful model inputs. Learning paradigms, supervised and unsupervised distinction. Model evaluation, metrics for assessing performance. Clustering, unsupervised grouping with k-means. Decision trees, tree-based models with information measures. So what are the key takeaways we can take from this paper? And data science is iterative. Understand, prepare, model, evaluate, then deploy. Okay, and no single algorithm fits all problems. Choose based on data and objectives. Evaluation, metrics must align with business goals. In interpretably and accuracy require careful balance. Domain expertise remains essential despite algorithmic sophistication. Thanks for watching. If you found these solutions helpful or Want to see more NSEM 2025 paper solved? Stick around and check out the other videos. Drop your questions in the comments and I will get you them. See you in next one. Okay, bye.